Okay, so we're going to look at thermal properties of metal question. This is a paper 2 section A question. So let's read the question. Figure 1 shows part of a machine to make coffee. The water is heated and changes into steam. The steam is produced at 100 degrees and is used to make heat milk. The machine initially contains 500 grams of boiling water. The heater transfers 1.2 kilojoules of energy to the water per second. The heater switches off when 100 grams of water remains in the machine. The specific latent heat of vaporization of water is 2250 joules per gram. So some of the keywords you need to remember is that the water is already boiling, so any energy supply is only to the latent heat. The second thing you need to know is that 100 gram is the final mass of water, so the change in the mass is more important than the final mass. So I'm going to skip the first part of the question, which is just a definition question, and we'll go to the second part, which is to calculate the time for which the machine produces steam. So let's remember that this question is a question on heat transfer. So the heat transfer is from the energy produced by the heater, and the energy is totally absorbed by the water. So energy is totally transferred without any loss. So again, this is a concept of the principle of conservation of energy. So let's look at how to calculate. For the heater, we will have to use the formula of power times time. And for the water, we will have to use MLV, as we are aware that it is already boiling water. So only energy absorbed is only on latent heat. We also is aware that we are only given the initial and the final mass, so the change of mass is the mass of water that has been boiled off, which is actually 400 grams. So this is the mass that has absorbed the energy from the heater and boiled off. So the energy supply is 1.2 kilowatt multiplied by 1000 to convert to watts, multiplied by the unknown time, is equal to 400 grams, which is the change of mass, multiplied by the specific latent heat of vaporization of water. So from there, we found that the time taken is 750 seconds. So that's the answer for part 2. So let's move on to the last part, which is a very interesting question. People who use the coffee making machine must be careful not to injure themselves. Explain why a jet of steam is much more dangerous than the same mass of boiling water. So this is actually a very interesting question, because we need to remember that steam will condense when it touches our hand. So when it condenses, it releases latent heat. But for boiling water, when it touches our hand, it will only cool. So when it cools, it releases specific heat capacity, right? Specific heat. So the question is, which one is release a lot more energy? Let's look at latent heat versus specific heat capacity. Specific heat capacity of water is only 4.2 joules per gram per degree Celsius, while latent heat is 2250 joules per gram. So it is almost like 500 times bigger than this. So you can imagine the magnitude difference between specific capacity and latent heat. So we can actually do a simple calculation to compare the two. So let's say we have 500 grams of steam versus 500 grams of boiling water, and the boiling water is going to cool from 100 degrees to 20 degrees, while the steam only condense, alright? Only condense. So it's going to be a little bit unfair for the steam, because when the steam condenses, it will also become water and the water will cool. So let's just compare between the condensation of the steam and the cooling of water, alright, to be a little bit more unfair. So for the steam, it's MLV, so 500 grams times 2250 will give you 1,125,000 joules. But for boiling water, you use MC delta theta is 500 times 4.2 times 80 from 100 to 20 degrees, change of temperature. It's only 168,000 joules. Look at these two figures. This one is almost 10 times more than this one. So just by the process of condensation, we are actually producing almost 10 times more heat than cooling down boiling water from 100 to 20 degrees. That's how much more energy is required to boil, to condense water or to boil water in the same light. Alright, so I leave it to you to write in your own ways, but the key is to mention, number one, that one releases latent heat, the other one releases specific heat, and number two, that the two values are significantly different. The latent heat is much larger, so the heat released by the steam is much more and it could cause much more damage. So that's how you should write your answer. Okay.